In this lecture, we are going to study about construction and operation of common base, NPN and PNP transistor. This is lecture 9 of unit 2, semiconductor physics. Now, what is a transistor? A transistor is a semiconductor device consisting of three regions, that is the emitter, base and collector. The three regions are separated by two PN junctions. Transistors are of two types, NPN transistor and PNP transistor. Electrons and holes are involved in current flow through an NPN or PNP transistor and hence are called bipolar junction transistor. Now you can see the picture of a NPN and a PNP transistor. It has got three regions, the emitter, the base and the collector. So emitter is heavily doped. It injects electrons into the base. Base is lightly doped and thin. Collector doping is between heavy doping of emitter and light doping of the base. Now, the collector collects electrons from base. It dissipates a lot of heat and hence is the largest of the three regions. The transistor has two junctions. One junction between the emitter and the base, called as the emitter base junction, and the other between the base and the collector, called as the collector base junction. So in terms of doping, the emitter is very heavily doped and the base is lightly doped, whereas the doping of the collector is between that of the emitter and the base. Size wise, the collector is very large in size and the base is very thin in size. Now this diagram over here is a representation of a transistor. Both we have an NPN and a PNP transistor. The arrow in the representation is between the base and emitter. The direction of the arrow is the direction of flow of conventional current, that is the direction of flow of holes. Conventional current direction is opposite to the direction of flow of electrons. In NPN transistor, the arrow points from base to emitter. In PNP transistor, the arrow points from the emitter to the base. So this is the representation of a transistor. What are the different types of biasing in a transistor? We know that the transistor has got two types of junctions. One is the emitter base junction, the collector base junction. If both are forward biased, then the transistor is said to be operating in the saturation region. If both are reversed biased, then the transistor is said to be operating in the cutoff region. If the emitter base junction is reversed biased and collector base junction is forward biased, the transistor is in the inverted mode. The last mode is emitter base junction is forward biased, collector base junction is reversed biased, then the transistor is said to be in the active region or normal mode. We will be having a further discussions in this particular mode, that is the emitter base junction is forward biased and collector base junction is reversed biased and the transistor is in the active region or normal mode. Here we see the working of a common base NPN transistor. It has got the emitter, the base and the collector. Then it has got two junctions, the emitter base junction and the collector base junction. The emitter base junction is forward biased and collector base junction is reversed biased. So we have seen the emitter base junction of a transistor is forward biased, whereas collector base junction is reversed biased. This is the normal mode. Emitter is heavily doped. The forward bias causes the electrons in the N-type emitter to flow towards the base. This constitutes the emitter current IE. As these electrons flow through the P-type base, they tend to combine with holes because in P-type, holes are majority charge carriers. As the base is lightly doped and very thin, therefore only a few electrons, less than 5%, combine with holes to constitute the base current IB. The electrons which combine with the holes become valence electrons. These valence electrons flow down to holes and into the external base lead. This constitutes the base current IB. The remainder, more than 95%, cross over into the collector region to constitute the collector current IC. In this way, almost the entire emitter current flows in the collector circuit. The emitter current is the sum of collector and base current, or IE is equal to IB plus IC. Here we see large amount of heat is produced in the collector, and hence to dissipate heat, the collector region is made large. The ratio of number of electrons arriving at the collector to the number of electrons emitted by the emitter is called the base transportation factor, denoted by beta. Typically, beta is around 0.995. Next, we can see the working of a common base PNP transistor. It has got an emitter, base, and collector. Once again, there are two junctions, a junction between the emitter and the base, and a junction between the collector and the base. The emitter base junction is forward biased and collector base junction is reversed biased. That is what you see in the diagram. The emitter base junction of a transistor is forward biased, whereas collector base junction is reverse biased. This is the normal mode. Emitter is heavily doped. The forward bias voltage is small as compared to the reverse bias voltage. When forward bias is applied across the heavily doped emitter, the majority charge carriers, in this case it is holes, move towards the base. This causes the emitter current IE. The holes enter into the base. Base over here is the n-type material and combine with the electrons. The base is lightly doped, due to which only a few holes, less than 5%, combine with the electrons in the base. The remainder, more than 95%, cross into the collector region to constitute collector current IC. In this way, almost the entire emitter current flows into the collector circuit. The reverse bias potential of the collector region causes high attractive force on the holes reaching the collector junction. Thus, the holes are attracted or collected at the collector. Current conduction within the PNP transistor is by holes. However, in the external connecting wires, the current is still by electrons. Once again, IE is equal to IB plus IC. So in this lecture, we have seen the working of a common base NPN and PNP transistor in normal mode.